Hello everyone, Miss Collins here again with another algebra lesson for you. So we are still in chapter 4. We are in section 4-5 and we're still continuing in this concept of comparing quantities and making sense of them and how they relate to each other. So today we're going to be talking about how to write a function rule, which is basically an equation that is going to relate to variables. So what I'd like for you to be able to do is to write equations based off of given information about specific functions. That's what I would love for you to be able to do by the end of the notes today. Alrighty, so first I would like for you to recall that the dependent variable changes in response to the independent variable. Meaning the dependent variable depends, just like a child depends on their parent, the dependent variable depends on what the independent variable's value is. So there are many real-world relationships that can be represented with equations. For example, profits or let's see here, speed going down the highway and different things like that. We're going to put some of these real-world examples into algebraic form for today. So in our first example, it says, you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit more than 1/4 of the number of chirps a cricket makes in 1 minute. What is a function rule that represents this situation? Well, what I want you to do when you are looking at word problems and you're trying to organize them or write an equation, the first thing you've got to know is what are the variables. So the variables are the temperature, T. So I'm just going to say T equals temperature. But also how many times the cricket chirps. So I'm going to say N is equal to the number of chirps of the cricket. Now I'm going to reread this again. It says the outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps a cricket makes in 1 minute. So the outdoor temperature, or T, but I'm just going to write it like this, temperature is 40 degrees more than 1/4 the number of chirps. So that's N. I'm going to go ahead and write N in there. So I'm condensing it down. Well, temperature is T. Is equal to, 40 stays the same. So the temperature is 40 degrees more than 1/4 of the chirps of the cricket. Well, more is going to mean addition, so I'm just going to put in a plus sign and then 1/4 N, and there we have it. That is our function rule. So you identify your variables, you start condensing the information until you get it down into nothing but mathematical symbols. For our next one, it says a landfill has 50,000 tons of waste in it. Each month, it accumulates an average of 420 more tons of weight. What is the function rule that represents the total amount of waste after M months? So my variables are W for waste and M for months. These are the two things, the two quantities that I'm comparing. And I gotta say, these are kind of some sad numbers. We are producing a lot of waste, aren't we? So let's reread the problem, and it says a landfill has 50,000 tons of waste in it. So where is the waste right now? The waste is equal to 50,000 tons. That's what this says right here. A landfill has 50,000 tons of waste. So the waste is equal to 50,000 tons. Each month, it accumulates an average of 420 more tons of waste. Well, this more is letting us know, oh, we've got a plus sign. How much more? 420. per what? Each month. So I'm going to put an M in there. And now I have my function rule all worked out. And that's it. We're just writing the equations for today. Or at least for that example, I should say. In example 2, it says a concert seating plan is shown below. Reserved seating is sold out. Total revenue from ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent this situation. What is the maximum possible total revenue? So my two variables in this are how much revenue or how much money are they going to make based off of how many tickets they sell. So I'm going to say R is equal to revenue. And then I'm going to say N is equal to number of general tickets sold. Now, based off of how much they're making money off of reserved seating and general seating. But how can we determine the amount of money that they make? Well, it's the price per seat as well as how many seats there are. So we need the price as well as how many seats there are. So let's get some of that stuff organized first. This is 10 rows of 12 seats. So that means that there are going to be 120 seats in this front reserved seating area. Over here it says there are 30 rows of 16 seats, so that is going to be, let's see here, 480. So here we have 480 seats. Alrighty, now let's start breaking down about how they make revenue. So we know the revenue, or R, is going to equal everything that they earned already for the reserved seating. So that's $25 per 120. So I'm going to say 25 times 120. That's what we're earning here. But we're also going to be selling more tickets, so that's why I get a plus sign. Plus $10 for however many seats we sell. So it's going to be 10 in. Because I don't really know if I'm going to sell all 480 seats completely sold out. That would just be, you know, best case scenario. So my final answer is going to be revenue is equal to 3,000 plus 10 in. Now it does say what is the maximum possible total revenue. That would be if all of the seats in the back are filled in, or tickets were purchased for every last seat. So I'm going to take this 480, substitute it in for N, and that's what we should get. So I'm going to get R is equal to 3,000 plus 10 times 480. So then the revenue is going to equal $7,800. If they were to sell out every single last seat in this back section in the general seating, then they would earn $7,800. And that's all we had to answer for that one. Let's look at a couple more word problems. Oh, if you can see it, there we go. This one says, a kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost for N days of boarding plus a bath. How much does a 10-day stay cost? So what are my two variables? We are comparing total cost with how many days there are. So I'm going to say C is equal to cost. N is equal to number of days. So the cost C is going to equal, and here it says a kennel charges $15 per day. Well, if day is represented by N and it's $15 per day, then that's going to be 15 N. And then it goes on to say, upon arrival, each dog must have a flea bath that costs $12. Well, that's not $12 every single day. That's just a one-time fee to make sure, I guess, that the dog is clean and it's not going to pass fleas to everybody. So it's just $15 per day plus a one-time fee of $12, and that's my function rule. Now it does ask, how much does a 10-day stay cost? Well, if 10 days were to be substituted in for in, then I'm just going to stick a 10 in there. So this is 15 times 10 plus 12. And that's going to get me, the cost is equal to $162. So once again, we had two answers for that. We had the function rule and then a what if scenario for an actual numerical value. We only have one more type of example to talk about, so because these next two are very similar. Example 3 says, write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when its width is 9 feet? Okay, so we're writing a function rule for the area of something, of a rectangle to be specific. So what I'm going to do, I'm going to draw a rectangle first. It's very helpful to draw pictures. And we know that area is equal to length times width of a rectangle. So I'm just writing down things that I already know to kind of help me organize my work. Now, I'm not told much about the variables other than the fact the length is 5 feet more than its width. So let's just label the width W. And if the length is 5 more than that, then it's going to be W plus 5. I know these aren't numbers, but we can still substitute them in for length and width. So now my area is going to equal W plus 5 times W. Multiply all that together, so I get area is equal to W squared plus 5W. And there's my function rule. Now then it says, what is the area of the rectangle when its width is 9? Well, width is 9 is going to be substituted in for W. So I can just work this over to the side and say area is equal to 9 squared plus 5 times 9. Because it's saying W is 9 and this equation has nothing but W's in it, so I am allowed to use it. This is going to be 81 plus 45, and that gets me 100. Yeah. 26 feet squared. I second guessed myself for a second. But yes, 126 feet squared should be that solution. So we're going to do the same thing again down here. It says write a function rule for the area of a rectangle whose length is 3 inches more than the width. What is the area of the rectangle when its width is 7 inches? So draw your rectangle. The area is equal to length times width. And here it says the rectangle whose length is 3 inches more than the width. So the width is just W, and the length is 3 more than that. So it's W plus 3. Well, the area is equal to the length times the width, so let's multiply those together. Area is going to equal W plus 3 times W, which is going to equal W squared plus 3W. There's my function rule. But what if, just in this particular situation, the width is 7 inches? Well, I'm going to take this 7, and I'm going to substitute it in for W, and I'm going to get area is equal to 7 squared plus 3 times 7, which is equal to 49 plus 21. So then that area is going to be 70 inches squared for my final solution. And there you have it. That is writing a function rule. Remember, the main steps are to identify your variables, and then you're going to condense their relationships with one another into math symbols. All right, if you have questions, make sure to bring them to me tomorrow in class, and have a good night.